Connected. Recording. Okay, everybody. We're going to get started now. So a couple of things I want to just go over. If anybody is going to be trying to do the dyeing at home with the dye kit, so you should just make sure that it's open, laid out on the table so that all the parts are ready and available. Make sure the flashlight has batteries because that'll be an important part. Although, I guess you could theoretically work outside, but that'll be too hard if you want to take it and move it out into the sun. I don't know, people are in different parts of the country, so I'm not sure what the sun situation is all over the various areas that we have people listening to us from. I know that we have people in Australia, so they are probably not going to be able to put it out in the sun, being as it's the middle of the night. Okay, and the last part for people who aren't going to be doing the dyeing is to boil the water. Have it ready so that it's nice and hot. The hotter the better. Okay, well, let's get started. What we're going to do now is just a brief review to remind everybody where we were when we last ended the story, the quest for the rediscovery of Tekhelet. And if you remember, we talked about Rav Herzog, Rav Yitzchak Isaac Halevi Herzog, who wrote a doctorate on the topic of Hebrew porphyrology, which was the term he invented for the study of Tekhelet. And in his doctorate, he really wanted to believe that the snail, the sea snail, the Murex trunculus, was the chilazon source of the ancient dye. It was what the ancients seemed to be talking about, and Rav Herzog read Greek and Roman, so he could read his Aristotle or his Pliny or his Vitruvius in the original. He knew of many archaeological discoveries which pointed at the Murex trunculus as the source of dyes in ancient times, and he knew that those dyes were purple in the very, very general sense, so he was hopeful. But the problem was that all scientists at that time, and not only at that time, but even for the next, let's say, 25 years after Rav Herzog passed away in 1959, all scientists, all archaeologists, all naturalists, all historians, all marine biologists, essentially everybody, was of the opinion that sea snails can produce only a purple color. And that's where we are now, let's say 25 years after Rav Herzog's death, 1985, and up until that point. Everybody would like to believe, anybody who is searching for the ancient Tekhelet, everybody would like to believe it comes from the sea snail. It can't come from the sea snail, because that gives a purple. So either you're going to have to say that the Murex is the source of the Tekhelet, and the Tekhelet is not blue, but rather it's what we call purple, or you're going to have to say Tekhelet is blue, and we have not yet found, at least the Murex cannot be the source of the Tekhelet, and that is the riddle that Rav Herzog was not able to solve, and no one was able to solve, and that's where we're going to start out today. Today we have a very exciting lecture because we're going to be doing it on premises. And where are we now? You can see that we're not in my study at home. So where are we? Well, let's show you kind of where we are. Right outside of Jerusalem, on the way to the Dead Sea, in the heart of the Judean desert. Up the stairs where tzitzis are lining the stairway, a real stairway to heaven, I guess. And here we are, in the one and only Tekhelet factory, right outside of Kfar Adumim. And with me today, in the Tekhelet factory, is Joel Guberman, co-founder of the Tekhelet organization. Joel runs the factory, and Joel is, I would say, probably the greatest Tekhelet dyer since the times of Rav Shmuel Bar Yehuda, which is a long time ago. That's a pretty big title to wear, but I'll be honest with you, there haven't really been any Tekhelet dyers in the last 1,500 years. So to be the best one. And Joel is going to take us around the factory, and he's going to be doing the dyeing with us. Okay. So,
Maybe we'll start out with the dyeing first, because we want the dye to be in solution as long as possible, the wool to be in the solution as long as possible, so that we get the best results for our experiment. So we're going to start out with our experiment first, and anybody who has their kids will follow along with me, so I'll go a little bit slowly. For those who don't have the kids, it may seem a little slow, but it'll go smoothly, hopefully. After we get that set and underway, then we can go around and show you a little bit about the factory. And then we'll do review what exactly we have done, what's going on chemically, what's going on biologically, and a little bit more about how that riddle of changing from purple to blue can be solved.
Beautiful. Okay.
Can we have our Gemara source, Baruch, please?
Yes. Good. So what did the Gemara have to say about Tekhelet?
Okay, so we have a Gemara and Menachot. For those who have the kits, you have your instruction sheets. The Gemara is quoted on the top. For those who don't, or the other ones, you can follow it here in the Gemara and Menachot. Then the Gemara says, Amar le Abaya le Rav Shmuel bar Rav Yehuda. Abaya says the Shmuel bar is the son of Rav Yehuda. Ha-Techilta he-Chatzriatule. This Tekhelet, how do we dye it? Amar le, he says, so Maitina dam chilazon. We bring the blood of the snail. What we have here is, by the way, a snail that's been broken. And this is stain, the dye that came out of one snail. You see it's a very little bit. And if you can notice, color, it is a purple shade, not a blue. Maitina dam chilazon, the samanim. Samanim will be chemicals. It would be the way we translate today. Materials, right? So those are we're going to use different kinds of materials. Samanim. Ramin and luhu b'yora, we place it into a vessel for dyeing. Umar tachinale, we boil it and we have our boiling water. So that's what we're going to be doing. This, by the way, is a story in the Gemara of people going from Eretz Israel to Bavel, right? And things haven't changed that much. Here we are in Eretz Israel, and we're spreading out the word to Galut outside of Israel. And I want to know, well, how did they do it? Well, in Israel, they had the sea, had access to the snails, and there was still some of that industry going on. In Bavel, there was no access to the sea. The industry was closed, and they were very curious how it happened. So just like you are part of that curiosity.
And Abaye, of course, was a famous Amora that lived in Bavel, and Shmuel bar Yehuda was one of the Nechutas that came back and forth between Israel and Bavel. So right. So Abaye, this old Rav who probably knew a lot, asked this young Shmuel bar Yehuda who's coming from Israel, tell me, how do you make Tekhelet? That's the one thing he wanted to know. Big question.
Right. So here we go. Okay, so we're going to open up our kits. We have in your kit, oops, sorry about that. In the kit we have 2 beakers. We have your gloves. I'm sorry, I don't wear gloves, but you can wear gloves if you'd like to. We have our flashlight. We'll put that on the side over here. And what we need is our chemicals.
Samanim.
We have A, B, C, and D, just to make things easy. A is our dam chilazon, the blood of a snail. What we've done is taken the snail, broken it, taken out the glands, dried it, ground it, made into a powder, and that's Urex trunculus dam chilazon A.
And we'll show that process in just a minute.
Slippery fingers here. Okay, so we're going to take those A, dam chilazon, and place it into our beaker.
And anybody at home, of course, if you have A, you can put it into your beaker.
Right. Follow us now. You might want to take a little sniff, okay, just to see that it is real, authentic, dead snails. It has quite the smell.
For everybody at home, put your nose close to the screen. Is that okay?
Okay. So that's our dam chilazon. Okay. The Sterman chemicals. We're going to be doing an interesting chemical reaction called an oxidation reduction reaction, which we'll explain more in depth after we're done. As we said, we just want to get this reaction taking place. In order for the reaction to work, you have to start out with a basic solution. We use a base called sodium carbonate. You can use many different types of bases. So, very interesting that in the indoor, one of the area where we run a marine tour about Tekhelet, they found a pit with some broken snails in it and chunks of limestone. Limestone is a natural base. So that was something that they, one base that we know was used many times. We're using sodium carbonate to help the process.
I'm sure you can see that.
Yeah.
I think so. I mean, there's not really much to see. Joel just put in A and B, which was the dam chilazon, the dried chilazon, and then a little bit of the chemical which would turn it basic.
Okay, mark the Tekhelet. We're going to boil it. We're going to add boiling hot water. Okay, around 150 to 300 milliliters. Doesn't have to be exact. Okay,
right.
And we're going to stir it. Have a stir in your thing here.
Right. So if I remember correctly in the instructions, we say pour 180 milliliters of boiling hot water into the beaker that contains the packages, the contents of A and B.
Okay. We're now up to C, which is sodium dithionite, and sodium dithionite is a reducing agent. Reduction is actually what dissolves the dye. Now, in the ancient times, that process would take much longer, and they didn't have. This is one of the summoning that was not available in the times of the Talmud or earlier than that. And apparently, the way they would get around dissolving this dye was by using the snails and fermenting the snails. The snails would rot on a low heat for several days. So if you think this smells, can you imagine that one? Okay, and they would cook that, and then it would cause the dye to dissolve or go into reduction. For us, we'll just add this chemical after.
Right. If anybody read the sources that I sent out before Shabbat, there was a description from Pliny who talked about how the dyeing was done, and that was the way he explains it. Was on a low flame for 9 days or so, and the meat would begin to separate and rot. And this reduction would have occurred in that method through fermentation, although now with the chemicals and the chemistry that we understand today, we can do it a lot quicker.
Okay, so notice now the solution has changed its color and it's more greenish yellowish, which means the dye is dissolved. That really is actually very interesting and fits another, the continuation of the Gemara. The Gemara continues and says, let's say, we'll read it, okay, that they would put eggshell, take out a little bit from the solution and check it. They would do te'ima. Now the question that might be asked is, why does one have to do te'ima? What was the purpose of checking the dye? Well,
and an eggshell was like an ancient paper cup, right? It was something that you could use and then throw away afterwards. So they poured a little bit off and put it into this eggshell, and then did a mini dyeing.
Right. Exactly. They would do a mini dye inside this little eggshell. But why did they have to do this mini dyeing? Because when you look at the solution, you can't really tell what color it is, and if you don't know yet if it's really ready for dyeing, and we're going to see out why, because we might get different results depending on how much is exposed to the sun or otherwise. Okay, we're ready to put our wool in, except our wool is very, very delicate. It's very soft, nice wool. But before, we're going to break into it, but before we put the wool in, we have to add one more chemical, and that is citric acid. And we do that because we have a strong base, and the wool gets destroyed if we put it into a basic solution. So we'll neutralize our solution by adding by adding an acid. And our acid we're using here is citric acid, okay, which they had, and it causes a reaction and a bad smell, for those who don't know, okay.
By the way, the bad smell is all part of the story. We'll get to that in a few minutes.
Okay, so we're now going to, all those who have their beakers can follow me. We're going to split our solution in half. Okay. And now we have two beakers. One is the sediment from the snails will stay on the bottom of one of the beakers, and that's fine. It doesn't really affect the dyeing that much. Now comes the most important part of when we're dyeing for tzitzit. And that is that as opposed to dyeing wool just for any old thing, when we dye for tzitzit, it has to be done the shem mitzvah tzitzit. Now, if you look behind me here, we have this very nice sign, and everyone who does the dyeing or any other part of the making of the tzitzit from the dyeing onward has to make sure they're doing it in the shema. They have to have intent that they're doing it for a mitzvah. Now, the shema is it's like if you do something for math, you have to use your intellect. If you do something for kindness, for chesed, you use your emotions, or heart. If you do something for the shema, you have to use your neshama, right? So we're going to get our neshama all revved up, and we help the focus of the neshama. We say these words: everything I do today that's connected to the making of the tzitzit, I do for the sake of the making of the tzitzit. It's like, as we're soon going to have Pesach, when you make matzot. Anyone who's been to a factory, you hear them chanting of the Shem, matzah's mitzvah, the Shem mitzvah's matzah, whichever one they be on. It has to be, the Shema has to be done the same. So we're ready? Everyone follow after me. The Shem, mitzvah, tzitzit, and we'll place our wool into the tzitzit.
Okay, and there you go. You can see that we now have two beakers. They were prepared exactly the same way, and the wool was put into two of the beakers. But now Joel is going to... Okay. What are you going to do? Why do we have two beakers?
Well, one of them we're going to cover. This is for our experiment. One of them we're going to cover up, and the other one we're going to take, we'll put it outside. We're going to go outside here. We'll put it outside in the sun. We have a little bit of sun here left.
Joel is going to take this outside. He'll be back in a second. I'll come on. Joel is going to take it. We still, it's 6:15 here in the middle. It's about 6:15 here in the middle of the desert. Okay, are we on? I hope we're still on.
Just to give a little more light, I'm going to actually put the your flashlight. You can place that on top of your beaker like this. Open it up and place it on top of your beaker like that. And I'm going to do the same thing to add that, just to give it a little more light, because it's the end of the day and the sun is not that strong.
So Joel's just preparing the beaker that was in the sun, and now that it's in the sun, and he's going to leave it there, and everybody else, put your flashlights on one beaker, and the other beaker keep it as dark as possible, so that we can do this experiment and see what exactly it is that we're trying to do.
Okay, now we can all take a deep breath and not worry. Our process is now taking place, and the dyeing is going on as we speak. We want to show you around a little bit in the factory.
And actually, we want to try to understand for a second, where exactly did this, how do we catch the snails? Where do they live? And we want to find out a little bit more about them. It just so happens that here in the factory, we have some snails that are living quite happily. Maybe we'll take a look at them. This is going to be a little tricky because I'm going to be moving around.
You need to pour it in.
Yeah, I do. So. Good. Okay. Joe?
Yeah. Okay, so we have actually two aquariums. We're not going to go to this aquarium. It's a long, thin aquarium, and it looks just like the Mediterranean. Not very exciting. Green or blue or purple algae, rocks, and we have a couple of basic kinds of fish that are actually and away down to the other end of the aquarium, and our friend, Mr. Murex trunculus. So if you look, can you get up close over there, Baruch? You'll see there's a little rock on top of this larger rock, and that little rock there is actually snail. And I'm going to go and reach him and get him out.
Okay, this is an important thing. I hope I'm showing it well. Can you get him? He's stuck.
Yeah, he's stuck.
He doesn't like to come out.
It's okay.
Okay.
There we go. Okay.
All right, beautiful.
Fine. Okay, maybe we'll wait for the light so it doesn't...
Here, let's come back onto our little makeshift
snail. As opposed to fish, the snail is a very, very primitive kind of creature, and so he can live out of the water for a few hours at least. You'll notice it has a hard shell, and on the hard shell it's growing different kinds of algae, which makes it look exactly like the seabed. And that might be one of the explanations about the snail, that it says that its body is similar to the sea. So either that the color of the algae is similar to the sea, or that the algae growing on it makes it look just like a rock next to it. It needs all of that because the snail, like a turtle, is an animal that doesn't move very, very quick. And its protection is by its hasfa'ah, by its
camouflage.
Camouflage. That's what we're looking for. It's by its camouflage. Okay? The snail goes inside its shell like a turtle, and when you lift it up, it all goes inside. And this is the inside of it, and it's over here. There you go. You see that shiny black piece? That's called a tziporin, or like a fingernail. It's a similar kind of material as a fingernail, and that's the final closure when it goes inside. Some actually say that tziporin is the source for tziporin in the Ketoret, one of the spices for making the incense.
So why don't we take a look and see, I hope that this will work now. Let's take a look and see how we actually catch these snails. And we need quite a number of them.
Just before we do that, say goodbye to our friend. We're going to put him back into the aquarium.
Thank you for helping us, Murex. Okay, so we actually catch the snails today the same way they did 2,000 years ago. And that is to bait baskets or nets. After a few days, these snails, which are carnivores and eat meat or eat fish meat, so they'll be attached to these nets. We bring them up, and one by one, we open up the snails, break them open. Hatzad chilazon v'hapotz'o, says the Gemara. You break it open. The Gemara talks about breaking it open. Then we take out a specific gland that lives on the back of the snail, right where we know how to break it, right where we open it up. And that gland is the hypobranchial gland. Now notice that the yellow turns purple. And this is something that we've been talking about now for at least 2 weeks. The yellow is going to turn purple, and that is essentially the dye. So for any people out there who happen to be excited about snail anatomy, here you can actually see the yellow. Let me see if I can circle it. Right here on the snail, there's that yellow gland, which is what we take out of the snail. And the snail has this gland in a particular place, actually pretty close to the reproductive organs. I don't know if we're going to get a chance to talk about that, but it is an interesting. There's a reason for that. In any event, the yellow mucus will turn into this purple dye, and that's where we are at this junction. We took that dye. That purple dye is what we collected, and that was from the samamanim, the dam chilazon that we talked about, that we added to the dye, that. Okay. So, here we are talking about purple for already 2.5 weeks. Well, the time has come to explain and get the answer to this riddle. The answer to the riddle was actually discovered in 1985. And here's a picture of the professor, the gentleman who discovered this, giving his seminal paper, the paper that changed the face of Jewish law at one of a really, really important and well-attended halachic conventions. Actually not. It was a convention outside of Tokyo where Professor Otto Elsner gave this paper. The paper, The Dyeing with Murex Extract, an Unusual Dyeing Method of Wool to the Biblical Sky Blue. Now you can imagine people in the audience there outside of Japan in 1985. I wonder how many people really understood that Professor Elsner was actually cracking this 1,500-year-old code, which was going to be something so important to Jews around the world.
I just would like to add, that if you look at the paper, it says Otto Elsner and Ehud Spanier.
Yes.
Otto Elsner is a Zichrono Livracha, has passed away. Ehud Spanier is still alive and still a professor of marine biology in Haifa. Now, what's nice is that you see here actually a synthesis between a chemist and a marine biologist. When we take it to the next step after that, it'll be adding in the rabbinic side of it, Rabbi Leo Tapker. And that whole combination, that synthesis, is really what has allowed Tekhelet to come back and be developed. And I think it's very important. It was one of the important lessons that we have.
Absolutely. Anyway, this discovery that Professor Elsner found, the apocryphal story has it that the cause of the vile smell of the dyeing, as he was doing his research, he was asked to leave his laboratory. His colleagues couldn't take it. And they asked him to go out into the outside, and there he went outside, and he found, just like everyone had found, Paul Friedlander, the great chemist, and those chemists, if you remember last week that Rabbi Chaim Tversky talked about from the Smithsonian, he found exactly the same thing that they had found, which is if you dye with the Murex, you get a beautiful purple color. But that, Otto Elsner found, was true only on cloudy days. But on clear, sunny days, he didn't get purple, but rather he got blue. This discovery, and I'll read you from one of the things that he says because I think it's so important. We came to the conclusion that as we discovered the change of color due to irradiation, so did the ancient dyers. And most probably, Professor Elter says, this is something that would have been known. Not, of course, to Rabbi Herzog, because Rabbi Herzog did his work inside in the laboratory in England where there's no sun. But the ancient dyers who did their work on the shores of the Mediterranean in the bright, bright Mediterranean sun, they would have immediately discovered the effects of sunlight on the dye. So what exactly is happening? What exactly is happening here? Okay. Inside of the Murex snail, you have predominantly three dye colors that are mixed together. Three molecules that produce each of them a dye color. The first one, dibromo-indigo on the top, which is a very deep purple, maybe even a reddish purple. Monobromo-indigo, a purple color as well. And the reason it's called dibromo or monobromo is because it's an indigo molecule with dye 2 bromine atoms or 1 bromine atom. And then you also have a mix of indigo. Now, indigo, if you remember from last week, we talked about indigo. It was kala ilai. It was the fake Tekhelet. So, indigo is present in these snails as well. When it comes from a plant, it's of course not acceptable. But if it comes from a snail, well, that would be great. The only problem is, when these molecules, the mix of molecules, as they come out of the snail, they're predominantly dibromo-indigo, more towards the purple side. And that gives you, as you see from the tuft of wool right here, a beautiful purple color. Very lovely, but not Tekhelet. If only we could figure out some way of shifting the proportions here, the distribution of these three molecules, and turning them predominantly into blue, even if you have a little bit of monobromo-indigo and dibromo-indigo left, and you always will, because any kind of chemical process, you're probably not going to get rid of 100% of these trace elements. But if we could limit that and reduce proportionally the amount of dibromo and monobromo-indigo, and we only had indigo, or mostly indigo, well, then we would be able to get a beautiful blue dye. And that is precisely what happens under the influence of the sun. And I'm going to have a little animation here, which is going to explain both what Otto Elsner found and also what you and we are doing right now in terms of the dye. We start with, for our purposes, all we right now care about is the dibromo-indigo molecule. Yeah, there's a little bit of indigo in there, but that's only good for us. The big problem that we have to deal with is this dibromo-indigo molecule. Okay, and if you know, the dibromo-indigo molecule looks purple, like we saw the damchilazone, that A powder, and like I've been telling you all along, the purple that comes out of the snail. When we put it into reduction, if you remember Joel, when he added the sodium dithionite and put the whole solution into reduction, reduction means the oxygen molecules get a little bit of a charge. So the animation here has a charge around those oxygen molecules. In that state, the solution is no longer purple or blue or anything like that. It's that green or yellow color. And for those of you who have it in front of you, you can see it. Okay, in that yellow color, the dye is in solution, it's reduced, and only at this point, can you see that?
That's our yellow.
That's our yellow reduced dye.
For those chemists out there, we call that the leuco state.
Exactly, leuco meaning light or white. So this is the lighter state. Okay, in this stage, only when it is in reduced form, then, and this is what was discovered by Otto Elsner and probably by the ancient dyers, actually certainly by the ancient dyers, in that state, if you expose the dibromo molecule, the dibromo-indigo molecule, to ultraviolet radiation, which you'll find in sunlight and even in some of those LEDs that we have, and that's what it's going on under the light right now. Now what will happen then is the bromine atoms, the bond to the base fundamental indigo molecule, those bonds of the bromine atoms get broken, and the bromine will evaporate, or we don't care about it. For our, as long as all that we care about is it leaves our molecule. Now you're still in a reduced state, right? The oxygen molecules are still nice and charged. So the solution is not going to change color. It's still going to look that yellowish color. So you don't know by looking at it what exactly happened. In order to find out, you would have to do te'ima. You would have to see if you've debrominated the molecule enough. If you've debrominated the solution enough, you would take it, put it into a little bit of an eggshell, test it. And then what happens, and this is what we're going to do just in a few minutes, when we reoxidize the molecules, we've taken away the bromine, dibromo-indigo, minus the bromine. What do we have left, everyone together? Indigo. Indigo is kala ilan, exactly the same color as kala ilan, which is why the Gemara says there is no way to tell the difference between Tekhelet and kala ilan. Only HaKadosh Baruch Hu, only God can tell the difference, because they are chemically identical. They have come about from different sources. They may have different properties depending on some of the trace elements that go along with them, but as far as the color goes, there is no way to distinguish between kala ilan and true Tekhelet that came from the Chilazon. At least that was true in ancient times. Nowadays, in our times, we actually can look for those trace elements. If we find a little bit of dibromo-indigo or a little bit of monobromo-indigo, we can be absolutely certain that it came from a snail and not from a plant. So that is going to be very important for us to test ancient fabrics. Can we determine whether they were made with plant indigo or whether they were made with Tekhelet? We can, and we will. We'll talk about that in just a moment. Okay, before we get into this, should we? How long has the dye been sitting? So we'll you know what? We'll leave it for another couple of minutes. Why don't you tell us some of the other things that are going on here in the factory? Okay, we've got our wool. Let's assume that we get our wool. Is there anything else that we have to do here to?
When people come
to
when people come to the factory, we focus in on two different aspects. Again, synthesis, but here is the synthesis of dye from a marine snail and wool from a land animal, sheep. We have sheep, but we can't go outside now. Right now, actually, they were stolen, so we don't have them right now. But at times when we have the sheep here, the kids can come and see the sheep, see where the wool really starts off on the sheep. And we can focus in on also some of the Melachot Shabbat, the Lamed Tet 39 Melachot Shabbat, the definitions of work on Shabbat are connected to the making of the Begadim. The Begadim were used in the Mishkan, the clothes of the Kohen, and unique to the clothes of the Kohen were the colors of Tekhelet, Agamat, Salat, Shanim, Okay, so the first thing would be, we have our raw wool. Actually, I have some raw wool over here. Hold on, sorry.
Joel's going to get us some wool, and we can actually see. Well, if we have a few minutes, we'll take a look at the whole process. But here you can see it.
Okay, here is some raw wool. It's brownish, and it's dirty, and it's clumped, you know, kind of like someone that hasn't taken a shower for a very long time. That's what the hair of the wool will be like, the hair of the sheep. That's taken off the wool, off the sheep, by a process called gozes, or shearing. It's basically a haircut. It's done once a year around the springtime. And we did it last year. We had a very nice ceremony around Pesach time of Reshit Hagez doing the shearing of the sheep and then giving the first portion to a Kohen. From that, after that, you have Melabain.
By the way, if anybody wants to see that, on our website, Tekhelet.com, we have some videos, and you can actually see the Reshit Hagez, the shearing it and the giving it to the Kohen. It was a very exciting event.
Okay. So Melabain and Menapet. Melabain, like the word Laban, is bleaching. So the wool is bleached, cleaned with different kinds of soaps, etc. And then Menapet is combing. Because again, we said the wool fibers are all tangled up. So these are two simple types of combs. There are bigger machines that do this combing as well. And that would be niputs, or combing of the fibers to straighten them out so that they can go on to be processed in the next stage. For those people who buy tzitzit, we mentioned lishma, the things that we've done for the intent of making tzitzit. There is a question as to from which part of the process does one have to begin to make it lishma l'shem mitzvah. So there are those who are machmir, who are stringent and say that it must, even the niputs, even the combing must be done b'shem mitzvah. Most people don't hold that way, and I would say 95 to 98% of the tzitzit that we make and sell are mahadrin. That means that the shema, the intent of doing it for the mitzvah, is done from the spinning on, but not from the combing. Spinning then takes place, actually we have another building on the other side. Again, we can't go over there, it's too far for the camera. But we have a building that will show, that has a spinning machine, and you can see how it's done. But we're just very roughly, the wool is turned and pulled, making it into a thread or a string, and that is tviyah, or spinning. After that, for the tzitzit, there is a process called shazira,
Let's see if
which
we can
is
go
flying.
over.
We're going to try.
So we've got our threads of wool,
Right.
very fine threads of wool, and now we're going to apply those threads together in the process called
Shazira.
shazira.
Now, let's see if we can see it over here. These are 4 very thin strings, okay, that are just sitting next to each other, one next to each other, and 4. What we'll do here is we'll set it up on a machine. This is a hand machine, okay? Everything we do is done by hand, so it'd be the same mitzvah and handmade. And this particular string that's set up is set up like a Rambam, which is part white and part blue, and we'll go into that a little bit later.
So again, right here, if I can take you close, you'll see that on the little spindle, I hope you can see it, I don't know if I'm showing it well, on this little spindle that's beginning to twist.
Okay, well, if we're going to begin to twist, we'll have to do the shame, it's not the
Okay?
and twist it. And what that will do is that it'll get the string into one rope like of 4 threads together.
So 4 threads are plied or twisted together. This little spindle turns very quickly, and that's the way we do the shazira. And just as you can see, we've got this long getting factory here because we do very, very long strings of shazira so that it's efficient and we can do them all at the same time.
Now, if you see here, you have 1 string, but tzitzit are made up of kaful shmona. They're made up of 8 thin threads. So then what would be done would be that the 4 and the 4 would be put together. Let's try to do that right here. There we go.
Okay, so after you spin 4 threads together, you ply. Okay, you spun the wool into threads, and then you've taken 4 of those threads and plied them together. So now you have a string that is made of 4 threads. Now you're going to take 2 of those strings, each one made of 4 threads, and ply them together. You spin it, but now actually you spin it the opposite way. That gives a little bit more stability. Always for the right and express purposes. And those strings will be plied together. And that gives us what we know today, our minhag. I think the minhag all over, all communities of Jews, all different communities and groups of Jews today use tzitzit, what are called kaful shmona. 8 threads are plied together, and that's the way we do it here. The shazira is a little bit tricky and not easy to do. So it's actually one of the hardest parts of of making the strings, and especially when you're doing Rambam strings, it's very tricky to get the shazira just right. And we'll talk a little bit about those different types of Tekhelet that are made. Although I think that mostly we'll get into that next week when Rabbi Moise Navon will talk about some of the issues about Jewish law and Tekhelet, some of the very unique issues that come up when we're talking about Tekhelet. We'll see if we have time. If not, I'm sure Rabbi Navon will talk about it. You want to wait another 5 minutes? Okay, so we have another 5 minutes before we take out the dye. And I want to ask the question now. You know, we're putting in sodium dithionite, we're doing these chemical processes here, and all of these modern different things. Well, maybe you'll say to me, that all makes lovely sense for people today to figure out how you could have gotten a blue dye out of the snail. But maybe in ancient times they didn't know how to do that. Maybe in ancient times the dyers only were able to get purple, and if so, then we're back to the question that we had at the beginning of this class. Either Tekhelet was purple and it came from the snail, or something else must be Tekhelet, because Tekhelet has to be blue. But the snail in ancient times, they only knew how to get purple. That's my question, or a challenge that I'm putting forth. Can we know with any certainty that the ancient dyers had the technology and the knowledge to dye blue from the murex snails? And the answer is, unequivocally, yes. But this is something that we've only found out very, very, very recently, within the last 2 years. I'm quoting from an article here by Professor Zohar Amar from Bar-Ilan University and Nama Sukenik from the Israel Antiquities Authority. They studied hundreds and hundreds of fragments of fabric from the Wadi Murbat caves. And these caves were inhabited by soldiers and the administrative officials during the time of Bar Kokhba. The revolutionaries, the fighters, and the generals and the bookkeepers that ran and fought in Bar Kokhba's army. We're talking about 135 to the Common Era. 135 is the time of Rabbi Akiva, who was part of the Bar Kokhba revolution. One of the most important Tanaim, authors of the Mishnah, Rabbi Akiva. Now these fabrics, one of them, this fabric that you see the picture of here, under a microscope, was shown to have blue threads in it. Okay, blue threads. But how do I know that these threads came from a murex, from a sea snail? Maybe they came from some kind of a plant. Well, remember what I said before, that the snails start with a predominance of dibromo and monobromo indigo. And if you want to get the blue color from them, you have to change those mono and dibromo indigos into indigo. But if you're going to do that, you're going to be left with very, very small amounts of dibromo and monobromo indigo. You could never get rid of them. Any bromine that you find has to have come from the sea animal and not from the plant. So under analysis, HPLC, high performance or high pressure liquid chromatography, which is a very, very sensitive way of finding the precise molecular structure, the molecular makeup of these different dyes, Nama Sukenik and Zohar Amar were able to determine unequivocally that, and I'll read to you, therefore it can be determined with certainty, because of the monobromo and dibromo indigo, therefore it can be determined with certainty that the textile was dyed with genuine shellfish dye. It had to come from a sea creature and not from a plant. Not only that, but they were able to make a guess, because of different ratios that they found, which sea animal it came from, which species, the Hexaplex trunculus, our friend the Murex trunculus. And so it seems they conclude that during the dye process in ancient times, the dye solution was exposed to sunlight to produce the blue color. The ancient dyers in the times of Bar Kokhba knew in Israel, this is in Wadi Murbat in the Dead Sea, the ancient dyers in Israel in the times of the Mishnah knew how to produce a blue dye from the Murex trunculus, and I think that really is, as they say, a smoking gun. I don't know what we could ever hope to get. Maybe tzitzit that were tied with Tekhelet, but I don't think, short of that, and I doubt that those would survive 2,000 years, short of that, I don't think how we could ever find anything that could be as conclusive as this beautiful, tiny little fragment of a fabric that was found in some cave by the remnant of the Bar Kokhba fighters. Who would have ever known that 2,000 years later, that little fabric would be something that would give us a key into this most beautiful and precious of commandments. Joel, should we see what's going on with the dye?
So why don't we do that? What we'll do first is we're going to bring the one from outside.
Okay, beautiful. I think we're right on time. It's just the sun is just setting now here in Israel. It's such a beautiful time of night, looking out on these beautiful mountains.
Okay.
We had some rain this year, so we've got some green covering on the mountain.
This is the one that was out in the sun, and as you can see, it's still in its glucose state. It's still this yellowish greenish color. Okay.
Now we have to oxidize it. How are we going to find oxygen?
Oh, hold on. Here's the one that was underneath the can, so that no light was hitting it. So to oxidate,
you can't tell the difference, right? They look exactly the same because we can't see anything while they're in their glucose state.
Right. So we're going to take this one that was in the dark. Now, to oxidate it, the best way to do that will be to stick it into water. It'll get the sodium dicyanide out of it as quick as possible and put the oxygen in as quick as possible. So first we're going to just take it out of the solution.
Wear your gloves for this, anybody who has...
if you want, you could go ahead and wear your gloves.
You don't want to have purple fingers for the next few weeks.
I won't stick to it. Here we go. So you see, there it is. Actually, I'm going to squeeze it out. It's still yellow, and there's very slight changes on the edges.
The oxygen in the air already starts to cause the transformation back to its original color.
We're starting to see the change take place.
And this was not in the sun. So when this comes out, there should be a very strong purple component to it.
I'm going to put it in the water just so that we can get it to oxidate quicker. And they're
hard to see on a tiny little laptop camera what exactly the colors are here. But I'll hold this here, Joel, while you do the other one. Maybe at least you can be able to see the difference in color. I'm looking at this now, and it looks like a very dark blue. There's a violet component to it, no question about it. If I was looking at this, I would kind of say this is, violet. And now here's the other one that Joel just took out.
Okay, and it's starting to change.
Starting to change color.
Let's see the differences.
Okay, let's put it in the water so that it'll oxidate a little quicker and get the sodium dicyanide, the reducing agent, out of it. Okay, maybe, now you can actually see the difference. It takes a few minutes as they get stronger and stronger, but I hope everybody can see, and I hope that it happened and worked for you at home. There's absolutely a difference. Here you have a purple or a dark violet, and here you have a gorgeous sky blue. The only difference between these, there was no difference in the chemicals, there was no difference in the snails, there was no difference in anything along the time of process, how long they sat in solution. The only difference was this was exposed to sunlight and this purple was not. This purple, if Rabbi Herzog saw that, he would say, lovely color, but not Tekhelet. If he, Rav Herzog, would have had the zechut to be able to see the results of the experiments of Otto Elsner and the blue, I think he would have ended his doctorate a little bit differently, with certainty in identifying the Tekhelet instead of the doubt that he had.
Well, I think it's really great that we have the zechut of following in the footsteps of such great giants as the Rebbe from Radin and Rav Herzog, and being them leaving us just a little bit more work to be done in order to get to the point where people could actually wear a Tekhelet made from the murex trunculus snail, a blue color that's really so nice and so significant.
So significant.
Can we leave anyone have any questions that they wanted to ask right now? Because we have just a minute or two before we go on.
Right. I want to make sure that we... I
don't know exactly how that works.
We have a minute. I want to show you the rest of the process. We've seen some of this. Remember, Joel put the samamanim in, the chemicals, and sometimes we have sunlight, which is great. Sometimes we put it under a sun lamp if it's a little bit cloudy outside. Dipping the wool into the solution and then taking it out afterwards and washing it like we did. And after it's been exposed to sunlight, you're going to get this beautiful blue. And some of the things that Joel had been talking about, we'll just see them a little bit closer now. Gozes, shearing the sheep. And then after the sheep are sheared, you take all of that sheep together, bleach it, right? So that it's nice and clean and white in this process. And then the niputs is done here. We have somebody doing the niputs in a little bit of a different way, straightening out the fibers, niputs. After that, we spin it. The wool is spun into fine threads, tviyah. This is shazira, like we saw. Taking those 4 threads and spinning them together on the spindle, plying them together, and then taking 2 of those and plying them together to get kaful shmona, 8 ply. And essentially that is the way we make Tekhelet. Of course, how do you tie Tekhelet? How many strings should be Tekhelet? 1 out of 8? 2 out of 8? Maybe it should be 4 out of 8? Those questions are things that Rabbi Navon is going to deal with. And how do you tie it? Many, many different methods. All of these things are issues that never had to be dealt with before, but they absolutely have to be dealt with now. And we're so lucky to be part of a generation that is asking these questions, is arguing over these questions, very, very heated debates about how exactly you wear Tekhelet. But that is, in our opinion, just such a wonderful thing to be part of those debates. So let's look again for a second as we close now on this whole process. And I want to look at this midrash and the saying of Rav Meir. So, what does this mean to you?
Okay, well, so Rav Meir had a very deep statement. He said, what's unique about this Tekhelet? I mean, we've been have these sessions and been learning about it and so on, but, for us, especially today that have so many colors, so we have a little color. What's so unique and special about it? So it says, Tekhelet domeh leyam, yam domeh l'rakia, v'rakia l'kisei hakavod. That Tekhelet reminds us of the sea of the sky, and the sky of God's holy throne. There's something unique about those 3 things, if we look at them in depth a little bit more. The sea, okay, symbolizes something very deep, and obviously a color. What color would that be? Blue, okay? Not surprising, is it? And then he brings us that from the depths of the sea, he takes us up to the heights of the sky, and he says, well, look out at the sky, we'll see, again, what color? A beautiful blue. That's the rakia. And then the kisei hakavod actually continues on in the midrash. It's kisei hakavod, itach v'raglav kilevnat sapir. Kiviyachol, so to speak, under God's throne is a sapphire brick, sapphire, again, being blue, also obviously referring maybe to the sapphire of the Aseret Dibrot, to the Torah, and so on. Many, many messages behind it, but I think one message that I'd like to leave everyone with, and a message that resonates with me, is that there's something very unique about those 3 things. We take the sea, which is beautiful, and we look out at the sea, we see endless beautiful blue. It's something like Ein Sof, something that reminds us, Kiviyachol, so to speak, that there's no end. Thinking of God, also something that has no end. But if we take a cup of seawater, in fact, it'll be clear, right? And the same would be true of the sky. The sky here, here's a little cup of water, right? In case you're not sure, you see that? It's clear. In fact, we can show you our beautiful aquarium. This is to see Marabu Ma'asecha, the beauty of God's creations. This is the deep sea. This would be more like in the Red Sea and Eilat, all these beautiful fish and colors and corals and so on. But that seawater, that blue seawater that we all see is in fact clear when we just take a cup of it. And the sky is also clear. If we take a cup of air, it's clear. And the kisei hakavod, that sapphire brick, well, if we see that sapphire brick very clearly, I think we're in big trouble. In fact, we don't see God so very, very clearly. We don't see that. We don't have a vision of God unless we're super prophets. We don't have a very clear vision of God. So you could look at the sea and the sky and see endless beauty and see the beauty of creation and see the wonders of God. And you look at the same sea and the same sky and see nothing at all. So in fact, seeing God, feeling the spirituality, realizing that there is a creator, is very difficult. And God gave us a commandment that would help us to relate to that very amorphous, very difficult concept of God, and that is the feel Tekhelet. We'll look at that blue thread and remember that even though we may not always see God in everything, it may seem transparent. We may not be able to see all the things and the beauty of God, we have to remember, constantly be reminding ourselves that, in fact, the whole world, all of things are created from God. And when we keep that in mind, we'll look at our tzitzit and think, the remembrance will also bring us to actually do them. And as Jews, we realize that not only do we have to have emunah, we have to have faith in God, we also have to have act in the proper way, act in a way of doing tikkun olam, of improving the world, and doing tikkun of ourselves, improving ourselves. And the Tekhelet will hopefully keep us on track with that message.
It's a matter of perspective. It's a beautiful idea. Thank you, Joel. It really is something so true in everything that we look at and everything that we see. You know, you can look at the most beautiful thing and see nothing if you're not willing to stop and really just take a step back, look at things in perspective. But there's so much beauty in the world and there's so much good. Maybe we should focus on that. I want to just say goodbye to everyone, but I do want to say one thing. You know, here we are in the Tekhelet factory, and we come to the Tekhelet factory. Joel comes here every day, makes Tekhelet, thousands, tens of thousands of sets a year. Tekhelet production has not enjoyed this kind of a wide scale, certainly for the last 2,000 years, certainly for the last 2,000 years since the Guberman. Only a few people wore Tekhelet, even during the times of the Mishnah and the later times of the Gemara. Here we're talking about tens of thousands of people, and maybe even by now hundreds of thousands of people that are wearing Tekhelet, and that is all happening from this little factory here in Kfar Adumim. From here, all of the Tekhelet comes out. You know, and sometimes people say, and Joel, I don't know if you feel the same way. People ask me, you know, how is it that you can take on this responsibility to make Tekhelet for all of the world, for all of Am Yisrael? Who are you, right? Who are you?
I've heard of that.
And so I think we've seen the answer today to a certain extent, and that's what I answer them. You know where Tekhelet comes from? It comes from a little snail. If snails can make Tekhelet, we can make Tekhelet, and if we can make Tekhelet for Am Yisrael, then our hope is that Am Yisrael will take it the way that we mean it, with all of the sincerity, with all of the kavanah, with all of the intentions, and this is something that we can bring back to the world. And so I want to thank Joel. I want to thank Joel for joining us today, and I want to thank Joel in general for all of the work that he has done in bringing Tekhelet back to Jewish people.
And I want to thank Baruch not only for all the work and being a partner together in this exciting journey, but also in particular about this four-part series, which really is a nice series and a way for us to spread the idea and give you an opportunity to feel a little bit closer. And as Baruch mentioned, we learn a lot of things from the snail, you know. One of the things we can learn from that snail is at the bottom of the sea. It's a humble creature. And I think that Baruch and Ari and Rav Tevger in particular are people who really teach and show their humility, and that's something that I like to learn from the three of them and from the snail. And
we should, next week, we have another special treat. Rabbi Moise Navon, who is a real scholar and quite knowledgeable about many of the laws of Tekhelet, will join us, and he'll go into some depth on some of the other issues and some of the other things that we haven't yet touched on. So I want to thank everybody. If you have questions, we'll try to stay on for a little while. If not, then again, please feel free to email me, and I'll try to get to them as best as we can. Thanks again to everyone.
Good evening, everyone.